for today's class, we're going to learn about average rate of change, and this is the same thing as slope, which you should all be very familiar with. So if you need that reminder, it is the same thing as slope. And as we go through today, we're doing a video rather than listening in class, just for those of you who went to the game on Thursday and maybe need to make up the test in class. But let's go ahead and let's start with some things that we should already know. So if you look at this picture and I ask you to calculate the slope between these 2 points, and you should be familiar, if I'm asking you basically the average rate of change or slope, you should think to yourself, oh, well, let's just go ahead and do rise over run, right? So if you have a picture, I often think it's easiest to count. So you're like, okay, well, how many am I going down? I'm going down 1, and notice 2 boxes is like 1 space on this graph. I'm going down 2, 3, 4 spaces, and if you go down 4 spaces, that's a rise of -4. And I'm going over 1, 2, 3, 4. So that's right 4, that's a +4. So using the picture, my rise is -4, meaning I'm going down 4. My run is 4, meaning I'm going right 4. So when I do -4 divided by 4, I have a slope of -1. And if you have a picture, great. I think that equation works wonderfully, and that's what I'd recommend using. However, last year you should have learned about the slope equation, so y2 minus y1 divided by x2 minus x1. And that's going to be the same idea here. When we're trying to find slope, and we maybe just have 2 points, then you probably want to use more like the change in y over the change in your x values. If you wanted to get fancy, we know y2 would be the same as f of x2, because f of x is the same as y. So that's kind of like the big boy equation. This is just what you learned previously, but as you continue to study math, you'll probably see it more like that equation. So let's identify our 2 points. They are -2, 3, and then we also have 2, -1. It doesn't matter which one you label x1, y1, as long as you keep the y's, the 1's together. So I could be like x1, y1 here, or x2, y2 here. Okay, and now all you're doing is you're plugging this equation. My y2 value is -1, so -1 minus my y1 value is 3, minus 3, divided by x2 is 2, minus x1 is a -2. Then you're welcome to either type things in your calculator, or you could just be like -1 minus 3 is a -4. 2 minus a -2, when you subtract a negative, that's the same as adding, so that's like 2 plus 2, which is +4. And -1 divided by 4 is a -1. So notice it doesn't matter if you count on your graph or use the equation, you should still get the same average rate of change or slope of -1. Okay, so that's from a graph. I do want to tell you, so in most cases, it's not realistic to travel at a constant speed for an entire trip. In these cases, however, it is possible to calculate the average speed that was traveled between specific time intervals. And that's where we get this idea of average rate of change. It's the slope of an imaginary line between 2 specific points in a function. Calculating the average rate of change is the same as calculating slope. So slope would be something that's constant with linear equations. Average rate of change could be with any function. So notice these ones, these aren't linear because they're not just straight lines. They've got some different curves and things like that. And so that's why we call it average rate of change, because it's not going to just be a constant number. So here when it says find Antonio, so notice Antonio is kind of this lighter line on your notes. Average rate of change on the interval x equals 2 to x equals 5. We literally have to go on our graph and be like, okay, so this is my x-axis, it's time. When x is 2, think of finding f of 2, we're saying, okay, it's at this point here, which is like a half. When x is 5, so 3, 4, 5, we also have to find where it is on Antonio's line, which is up at 2. And you can either choose, if you like the equation, great, identify the points and use that, or otherwise you could just count. You could be like, okay, to get between these 2 points, I'm going up 1, 2, 3, but be careful. Each of those boxes are only a half, so we're going up 3 halves, or up 1.5. I'm going over 1, 2, 3. And then these, like on the x-axis, it is actually over 3. So we're going, our rise is 1.5 over 3. At that stage, you may want to simplify it, because 1.5 divided by 3 may not have much significance to you. So like 1.5 divided by 3 is equal to 0.5. So our average rate of change between those 2 points is 0.5. Okay, the next thing we want to do is we want to find out between 11 and 15. So once again, you go on your graph, we're up at 11, and then at 15 for Antonio is all the way up here. So saying, what's this average rate of change? We're going up a half, a whole, another half, so we're going up 1.5. We're going over 1, 2, 3, 4 this time though. So up 1.5 over 4, we know it's got to be slightly smaller than a half. If we use our calculator to do 1.5 divided by 4, we get 0.375. So if I asked you which interval above, so out of 2 to 5 and 11 to 15 had the greatest average rate of change, we're looking for which one had the biggest number. So Antonio's average rate of change on the interval x equals 2 and x equals 5 had the greatest, right? Because it was a bigger number. And what does this look like on the graph? On the graph, it's hard to tell, but if we connect those points, so it's that imaginary line between those 2 points, you'll notice that this line is slightly steeper than that one. And we may see it a little bit better in some of these other examples, but anything that is steeper is going to have a greater average rate of change. And that makes sense, because the higher the number our slope is, the steeper it will be, and therefore the greatest. So now let's compare. It says, does Juan or Antonio have a greater average rate of change between 5 and 7? So if I look at 5, we're here versus here, and then 6, 7, we're talking about this point. Who has a greater average rate of change? We're saying, okay, who has a steeper slope here? Well, Antonio hasn't gone anywhere. He stayed there at a distance of 2 miles. So his slope effectively would be 0. But Juan has gone somewhere. He's gone a whole mile over those 2 minutes, right? So he, in this case, Juan, will have the greater average rate of change. And you can think of that because he has a steeper slope. You could even calculate if you wanted. He's going up 1 over 2 in this case. So 1/2 is going to be greater than 0. Either way, it will work out. And then it says, who wins the race? I guess, and how do you know? I guess I should have said it when the race ended. So if we said that it ends at 4 miles, who wins it? So let's say it ends at 4 miles. Then we're looking for who wins it. Well, as you look at the graph, we're saying, okay, who has a shorter time? So who gets to 4 miles quicker? So in this case, it looks like Juan gets to 4 miles quicker. It only takes him 13 minutes rather than Antonio's 15. So Juan wins the race. He's going to have a faster overall average rate of change since they started the first time, but he ended quicker. So that should get you pretty comfortable with doing it from a graph. Let's also look at it. We're going to have 2 other ways. We're going to look at it from an equation and from a table. So as we look at the next part from an equation, on this one it says consider the function f of x equals negative 3x plus 5. So we're going to have 3 different equations here. These are not the equation for average rate of change. They're simply different equations that we're looking for, like the slope on a specific interval. It says find the average rate of change in the interval 2 to 6. Be aware this interval is talking about x values. So we're saying from when x equals 2 to x equals 6. Okay? And then if we want to find the average rate of change, remember at the beginning I said the average rate of change is the same thing as what? Okay, you got it, slope. So here I could plug in the equations. I could be like, well, you know, f of 2, and when I plug that in, negative 3 times 2 is negative 6 plus 5 gives me negative 1. F of 6, when I do negative 3 times 6, negative 18 plus 5 is a negative negative 13. And then I could go ahead and plug my equation. So I'm like negative 13, let's say that's my y value, minus a negative 1, divided by my x value that goes along with the 13 is 6, minus 2. When I do that, I get negative 12, divided by 4. Oh, my average rate of change is negative 3 then. But let me save you some time. Average rate of change is the same thing as slope. So in linear equations, the slope will never change. We know our slope is negative 3. You don't even have to do any calculations. Just look at the equation, identify the slope of negative 3, and you're done. Move on. Whereas on number 9, this is going to be different because we have this x squared plus 3 as our function. This slope, or average rate of change, is not going to be constant. If you were to graph it, I'll go ahead and show you my graphing calculator. It makes this U shape, And we know that that rate of change is not going to be the same because it's getting steeper over time. So what you may want to do is we want to find the table of values. That would be an easy way to do it, to find those y values when x is 1 and x is 3. Your other option would be to plug it in like we did up here. So if I plug it into y equals x squared plus 3, and I go to my table of values, when x is 1, so f of 1, if I look at my calculator, f of 1 is going to be 4, whereas f of 3, if I go down to that, is going to be 12. I've got my x values is what I plugged in, and my y values are the 4 and the 12. So now let's go ahead and let's think about our equation. y2 minus y1. So we're saying just subtract the y values. It doesn't matter if you start with 4 or 12 first, but pick one and stick with it. So I go 12, minus 4. When I divide it by my x values, I've got to use the x value that matches 12, which is 3 minus 1. So make sure your ordered pairs are on top of each other. 12 minus 4 is 8. Divided by 3 minus 1 is 2. 8 divided by 2 is 4. So my average rate of change is 4. On this next one, I want you to pause the video for a minute and try it yourself. When you unpause, I'll go ahead and work through it. So we're finding now, as we go through it, we're trying to find the y values when x is 0 and x is 3. So we're plugging in 0 for x, and we're plugging 3 in for x. This one, rather than doing my calculator, I'll do it by hand, but you have the option to do it either way. So 4 times 2 to the 0, and 4 times 2 to the third, right? Because we're plugging in x being 0 and x being 3. 4 times 2 to the 0 is 1. 2 to the 0 is 1, 4 times 1 is 4. 4 to the third is 8 times 4 is 32. So we're doing, let's say I do the second one first. So I do 32 minus 4. If I start with 32, then I've got to do the x value that goes along with it, 3 minus 0. So we get 28 thirds. And if you don't like fractions, you could leave it like that, but if you don't like them, you like decimals better, that's equivalent to 9.3 repeating. Either way works out. Okay, I feel like tables are very similar to equations, whereas then you're finding the two ordered pairs and then you're just subtracting them like you did up here. So find the average rate of change in the interval 2 to 6. So we're saying when x is 2, and then make sure you do when x is 6. So we're talking about the point 29 and 6, 3. And then this one, you have the same option like we said before. It doesn't matter which y value you start with. Remember, h of x, another way of saying y. We can either start with 9 or 3, but choose one and make sure you do it in that order. So if I say I start with 3, and then I subtract the y value of 9, I've got to start with my x value of 6 minus 2. 3 minus 9 is a negative 6. 6 minus 2 is 4. You could simplify that to negative 3/2, or if you like decimals, negative 1.5. All of those answers are equivalent. They are your average rate of change. But you'll most likely see it as a decimal or that simplified fraction. Finally, on this last one, I want you to try again. Pause the video for a second and try it on your own, but you're finding the average rate of change between 2 and 5 years. So pause it, and when you come back, I'll explain it to you. So we're saying between 2 and 5. So on this one, since we're finding the change of height, we're going to look at the difference in our height. So maybe 45 minus 35 divided by years, and then 45 and 5 minus 2. So we're talking about 10 divided by 3, which is the same as 3.3 repeating. Either of those fractions or decimal would be great. Hopefully this is enough to get started. Feel free to ask questions. You got a quick couple question quiz, and then you have the assignment to complete today. Good luck.